Hello, welcome back to another video. I haven't posted in a long time, all because of this. This is Minecraft's first true Redstone AI neural network. And yes, this was an absolute pain to build. I never want to build something like this ever again. Oh my. It's just way too complicated for me. I really took way too long doing this. I mean, the last time I posted a video was like a month ago, I think. But yeah, so first I'm going to explain to you how this works, and then I'm going to explain why I said that this is the first and only Redstone AI there is. So first, the explanation. So, how a neuron works is that it has two valors. Is that the word? I don't know. I know that's the word in French. It has two numbers going into it because I have two neurons in the input layer. The input layer doesn't really do anything. So this is the input layer. This is the middle layer, also called the hidden layer, and then this is the output layer. So how it works is that the input layer, just takes in inputs. Then it puts it into the output layer, the hidden layer, and each neuron is connected. So this is connected to this connected to that, connected, and connected. Each connection has their own weight. A weight basically, it's really important because without it, there isn't really much the neural network can do. So, first, a neuron takes a weight. Wait, did I write it down here? No, I don't think I wrote it here. I'm gonna just, explain it at the back of here. Okay. So first the neuron takes in a weight. So each connection has its own weight. So we're gonna do weight as W. So weight times Y. No, X. Oh wait, that looks similar. Okay, let's just choose C for connection. The inputs. So it does W times C. Then, and this is pretty important, you need to add a bias. Oh, where's addition? Oh, here. You need to add a bias. So basically, this is a graph where if there was no bias, and if there was a bias. So imagine that basically what the neural network does is that it gives out answers like depending on where it calculates on the graph, because that's really what a neural network, an AI, is. It's basically just a big graph that gives out a lot of numbers, and then those numbers can get translated into words, for example, for ChatGPT, or those numbers can be if something is poisonous or not, or if jumping from this altitude will kill you, blah blah blah. So, this is how you calculate something with only one connection. Obviously, if they're gonna be over here, there are two connections, because this neuron is connected to this, but this neuron is also connected to that. So we need two weights and two connections. So what we can do here is do weight 2 times C2 plus bias. Yeah, you get it. If we have a third connection and weight, such as over here, where there are 3 connections, then you just got to do another plus W3 times C3. So that is how a neuron calculates in front propagation. Front propagation is basically giving a result. But then we need to figure out if the neuron should even give out a signal or if it should not. So basically an AI tries to simulate our brain. That basically happens when like neurons in our brains don't fire. Basically when they don't connect, don't like light up. Oh my god, my voice is cracking. Okay. So that is called an activation function. So in my neural network, the activation function I choose is ReLU, which basically means that if the result is positive, then you can go past. If the result is negative, then nope. So yeah, and then that's literally what a neuron does. Everything a neuron does. Well, not the input layer. And then it travels through, and then we get our output. But as you guys can see, there is another step, which is the learning process, which is why neural networks are like wanted, because they can actually learn. Because otherwise, what's the point of making a neural network? Just give it a graph immediately. So yeah, oh wait, I just realized I didn't color code. I only color coded these like lines. It looks like a Christmas tree. Okay, yeah, it's like this, all of this over here. That is like an updater. So yeah, so for the machine to learn, it needs to change its weight and bias. So basically, it just changes, yeah, it literally just changes its weight and bias of every single connection. So yeah, that's how a neural network learns. And that is called backpropagation. This was called front propagation, and this is called backpropagation. So now, how do we actually make a neural network change its weight? So, wait, I wrote it in notes, in Notepad. Okay, yeah, so it is this, I think, yeah. Okay, so W means like the new weight, so what its new value will be, and W old, its old value. So first we need to do learn, which learn basically is something you input. Learning value is really important. Usually it's pretty low. You want something low. The lower it is, the better. I won't go into too much detail what it is. You can go watch other videos. But it's pretty important. Everything here is actually important. So then it does learn times loss. So loss is given at the very end. Total cost. Loss and cost is the same thing. Yeah, it took me months to realize this. I don't know why. No video actually says, oh yeah, by the way, loss and cost is the same thing. So that was a bit troublesome. But, oops. Yeah, this is what I was planning to do. Yep. Okay. So this is how you calculate the loss. So you do 0.5 times, so what your target value was, so what you wanted the output to be, minus what the output actually was, and then squared. So that result is the loss. Now, what the loss does, and then to calculate this, thing, you need the loss. So yeah, that's pretty important. And then ReLU of the neuron output. So if you remember before when I said that this thing does an activation function, over here for example, an activation function of ReLU, if it is positive, it is a tick. If it is negative, it, well, nothing. So because this is times ReLU neuron output, the ReLU output can only be a 1 for positive and a 0 for negative. So 1 and 0. So basically, if the neuron output was a 0, its weight does not get changed. If its output was a 1, then it gets changed. Well, yeah, if its output was positive, it gets changed. If its output was negative, the weights and biases inside do not change. And yeah, that is literally the entire neural network. Yeah, so this is what this entire system is. It literally just does all of that. And yeah, don't tell me, I've been working on this project for at least over a year now. I've been like researching, trying to understand, because I didn't find that there was any video clearly explaining everything. But I hope I clearly explained everything there. And yeah, so this system over here calculates the loss. And yeah, so now I'll be explaining why this right here is the only true Redstone neural network. So when someone says neural network, you might think of Crafty Masterman's a little
I have something really
invention.
exciting to saw in the title that it is a basic neural network.
So
but
Crafty Masterman does call this a neural network, but this thing cannot learn. It has no neurons, nor does it have any weight or bias. It's just a character recognition. An example for that would be in Redstone, if you want to build tic-tac-toe. Most people wouldn't build a Redstone computer and then put a tic-tac-toe program on it. Instead, they would build a machine that only does tic-tac-toe. This is kind of what this is. Instead of building a real neural network, he built something that does character recognition. So this thing is not a neural network because it has no neurons, no weights, and no bias. I should also add, that this machine does not actually learn. It's more of like a ROM, a very complicated ROM. But why people really like neural networks is that they can learn. So this thing cannot learn. So that is why it also is not a neural network. So the second thing you might think of when I say neural network is Crafty Masterman's Proggy. Now this thing, I'm sorry, Crafty Masterman, this is not even anything close to a neural network. This is just literally a ROM. It's just a RAM. It's not a neural network. It does not learn. It doesn't even use any information. It's just a RAM basically of a very like weird ROM. But other than that, it's not a neural network. I'm sorry, Captain Masterman. Sorry for hating so much. So, when I also say neural network, you might be thinking of Vanek Kilcher's neural network. Now this is impressive. This is probably the closest thing to a neural network there is, a Redstone neural network. The only problem here is that there is no bias, and as I explained before, the bias is really important. It allows for a graph, for its results to be more varied. It allows it to be smarter. So I guess one could call this a Minecraft neural network, but I mean, it wasn't even that hard to add a bias. I guess you could say that this is more like a baby neural network. Though if it was a true neural network, it needs a bias. So it's kind of sad that you didn't add a bias. But I mean, this is really impressive. This is still really impressive. Um, mine is using binary. It's 8-bit. I also allowed them to be I allowed there to be negative numbers, which is actually really not that hard actually. So it just makes it into 9-bit, and then yeah, that last bit is to say if it's negative or positive. Yeah, so that's pretty interesting. It allows for something like this to become something like that. So yeah, my neural network is far better than this, firstly, because this is analog. Mine is 8-bit. Plus, it has negatives and also a bias. But I guess you can consider this a neural network. Next, you might be thinking about cohomology's Redstone video, where he demonstrated a neural network. The thing is, this thing is very bizarre. So yeah, that is my neural network. I really hope you enjoyed this video. This video has taken so long to make. I've actually been researching this, trying to understand it for at least a year now, over a year I'd say. I started building this maybe a month or two ago. I had a ton of burnouts. I procrastinated a lot, I'm gonna be honest. But it is finally done. And I can get back to making all those other fun little redstone things and videos that like come out about every week. Oh my god, this was really complicated. I'm not even gonna use this. I don't know why I made this. Why did I make this? I don't know. I'm gonna show you a clip of me like finishing this. I don't know why, but yeah, it'll be fun. So, I guess thanks for watching, and bye. And here we